Hello everyone, welcome to our video presentation on the state of the art in distributed query processing by Donald Kosman. In this video, we delve into key topics of the state of the art in distributed query processing, which includes motivation, basic concepts, challenges, complexities, related work, proposed approach, contribution, validation, conclusion, future scope, and references. In motivation, as business evolve, the reliance on distributed data processing grows in tandem with their competitiveness. The need for efficient query processing in distribution is more pronounced than ever, driven by the inherent complexity and dynamic of nature and contemporary operations. While modern technology empowers distributed data processing, it also presents a host of challenges that must be navigated with finesse and innovation. Coming to basic concepts, in basic concept, distributed query processing involves the handling of queries across multiple sites in network environments. This process comprises several key components like query optimization, data distribution, and communication protocols. Let's see what is query optimization. Query optimization is a cornerstone of enhancing query performance by meticulously selecting the most efficient execution plan. In distributed systems, this becomes even more crucial due to the imperative to minimize resource usage and response time across multiple sites. Various techniques come into play in this query endeavor, including special join methods, exploiting inter-query parallelism, and implementing strategies to reduce communication costs, all geared towards achieving query optimization. This program presents a dynamic programming algorithm for query optimization. The input consists of SPJ query queue on relations R1 through Rn, and the goal is to generate a query plan for Q. The algorithm iterates over each relation Ri from 1 to n. For each iteration, it generates initial process plan and prunes them into deliver any redundant or inefficient plans. Then it proceeds to the main optimization loop. It iterates over all possible combination of relations, starting with the pairs and increasing size in unit, and all relations are included. For each combination of relations, it initializes an empty set of optimal plans. Then, for each subset of relation within the combination, it generates joint plans by combining optimal plans for the subset of the relations. These joint plans then prune to ensure efficiency. Finally, the algorithm returns the optimal plan for the entire set of relations R1 through Rn. The dynamic programming approach efficiently explores all possible query plans and selects the most optimal one, considering the join operation and access methods involved. In data distribution is a fundamental in distributed systems, encompassing the dissemination of data across multiple sites to streamline query execution. Its primary aim is to ensure that data is readily available and accessible across the distributed environment, thereby facilitating efficient query processing. To achieve this, various strategies are employed. Replication involves duplicating data across multiple sites, ensuring redundancy, and reducing access latency. Caching techniques are also utilized to dynamically distribute frequently accessed data, further enhancing system performance by minimizing data retrieval times. Communication protocols, which forms the backbone of the interaction within the distributed system, defining the rules for data exchange between various components. These protocols are essential for enabling seamless communication between nodes, ensuring that the data is transferred readily and consistently across the distributed environment. By facilitating effective communication, this protocol plays a crucial role in maintaining data consistency and coordinating query processing tasks among distributed nodes. Their implementation is paramount for the smooth operation of distributed systems as they govern the flow of information and uphold the system integrity. Coming to challenges, in challenges, navigating the complexities of distributed query processing presents a myriad of challenges, demanding the innovation solutions and strategies. These obstacles include fragmentation, latency, data heterogeneity, and optimization issues. are crucial factors in achieving seamless and efficient data processing across distributed systems. Let's see what is data fragmentation. Data fragmentation is nothing but managing data distributed across multiple sets introduces challenges such as fragmentation and potential inconsistencies. As data is spread out across various locations, it can be fragmented, making it challenging to ensure coherence and consistency across the distributed environment. This fragmentation can lead to dispensaries in data representation and accessibility, hindering effective query processing and analysis. Addressing these challenges requires robust strategies for data management and integration to migrate fragmentation and maintain data consistency across distributed sites. And network latency refers to delays in data transmission and communication between distributed sites, directly impacting query response time. As data travels from different nodes across the network, latency can occur due to factors such as network congestion, distance, and processing delays. These delays can significantly affect the time it takes for queries to be processed and responses to be received, ultimately impacting the overall performance of distributed systems. Minimizing network latency is crucial for optimizing query response times and improving the efficiency of data processing in distributed environments. In heterogeneous data sources present the challenges of making diverse data formats and structures from different origins, necessitate integration and compatibility efforts. As data is collected from various sources, it makes bit differences in formats, schemas, and semantics, making it challenging to seamlessly analyze and process. Dealing with this heterogeneity requires robust integration mechanisms to harmonize disparate data types and ensure compatibility across the distributed environment. Addressing these challenges enables effective utilization of diverse data sources for comprehensive analysis and decision making in distributed systems. Coming to query optimization is pivotal in ensuring query execution across distributed systems, aiming to minimize resource utilization and enhance overall performance. By carefully selecting the most efficient execution plans, query optimization reduces the computational overhead and data transmission requirements, thereby optimizing system resources. This process is crucial in distributed environments where the queries may span multiple sites, each with its own set of resources and limitations. Through effective query optimization, distributed systems can achieve improved response times, increased throughput, and enhanced scalability, ultimately maximizing their operational efficiency and effectiveness. In complexities, the complexity inherited in distributed systems manifests in various forms, including challenges related to data consistency, resource allocation, and query performance. Coming to data consistency in distributed systems is paramount, involving the preservation of data integrity and coherence across various distributed sites. This ensures that the results remain accurate and reliable without dispensaries or errors. Achieving data consistency requires mechanisms to synchronize and coordinate data updates and modification across all nodes in the distributed environments. By maintaining consistency, distributed systems can provide users with reliable and trustworthy data for making informed decisions and conducting meaningful analysis. Resource allocation. It involves the efficient distribution of resources such as processing power and memory to effectively handle the queries and meet the performance expectations. By allocating resources judicially, system can optimize query processing and ensure timely responses to user requests. This process requires careful planning and coordination to balance resources utilization across distributed nodes while minimizing bottlenecks and maximizing throughput. Effective resource allocation is essential for achieving optimal system performance and scalability in distributed environments, ultimately enhancing overall user experience. Coming to query performance, achieving optimal query performance is distributed environments is essential, especially considering the varying network conditions and data distribution present in such systems. In distributed system setups, queries may traverse multiple nodes across the network, encountering different levels of latency and data accessibility. Therefore, Optimizing query performance involves strategies to minimize the impact of these factors on execution times. By implementing efficient query processing techniques such as parallelism, data partitioning, and caching, system can mitigate the efforts of network latency and data distribution, ultimately improving overall query response time and system efficiency. In the realm of related work, examining prior research shed lights on the limitations, novelty of the paper, assumption limitations, critique of unreasonable assumptions. Let's see what are limitations. Limitations in existing research are evidential in several key areas, highlighting the need of advancements in distributed query processing. Firstly, previous solutions have predominantly focused on single node query processing, neglecting complexities inherent in distributed systems. This narrow focus limits the applicability of these solutions and fails to address the unique challenges posed by distributed query processing. Furthermore, existing approaches often overlook the dynamic nature of distributed systems, where nodes may join or leave the network dynamically. This lack of consideration for system dynamic hampers scalability and adaptability, hindering the effectiveness of query processing in distributed environments. Recognizing these limitations underscores the necessity of novel approaches that account for the distributed nature and dynamic character of the modern computing environments. By addressing these shortcomings, researchers can pave the way for more robust, scalable solutions in distributed query process. Coming to novelty of the paper, in this section, we see the novelty of these paper lines in its groundbreaking approach to distributed query processing, which addresses the distinctive challenges posed by distributed systems. Unlike previous solutions, this paper introduces a novel methodology that acknowledges and tackles the complexities inherited in distributed environments. By adapting to a holistic perspective, the proposed approach offers a comprehensive solution tailored to the interests of distributed query processing. Moreover, the paper introduces a cutting-edge, cost-based optimization framework that goes beyond traditional optimization techniques. By considering both data and network characteristics, this framework enables more efficient query execution, results in improved performance and resource utilization. By pioneering these innovative approaches, this paper contributes significantly to the advancement of data query processing, offering new insights and methodologies to enhance the efficiency and scalability of distributed systems. Now let's see what are the assumptions and the limitations. The assumption limitations of this paper highlight potential challenges in applying the proposed solutions in real-world distributed systems. One critical assumption is that all nodes within a distributed system possess equal processing power and network bandwidth. While simplifying the computational model, this assumption may not hold true in practice, as nodes in distributed systems often exhibit varied capabilities and resources. Coming to the critique for unreasonable assumption, the critique in unreasonable assumptions of equal processing power and network bandwidth underscores the potential limitations of proposed solutions in real-world distributed systems. This assumption fails to acknowledge the inherent variations in processing capabilities and network bandwidth across nodes in distributed system environments. In reality, node often exhibits diverse characteristics, resulting in heterogeneous computing environments. Coming to the proposed approach in different distributed query processing is centered around optimized system efficiency and query performance through innovative strategies and methodologies. By targeting key challenges such as data fragmentation, network latency, and heterogeneous data sources, the approach seeks to streamline query processing and enhance the overall effectiveness of the system. Coming to the contributions made by the research are significant and impactful. New methods are introduced to improve distributed query processing in complex modern systems, addressing the evolving challenges and distributed computing. Sophisticated algorithms enhance query efficiency in distributed systems, tackling fragmentation, latency, and optimization challenges. Enhanced distributed query processing for better systems efficiency and performance. These dynamical adjust query plans for real-time performance optimization. They also maintain the data consistency across distributed sites for reliable query results. All these offer practical solutions for industry challenges in distributed query processing, improving response time and scalability. By validating proposed techniques through rigorous experimentation, we have established their practicality and effectiveness in improving query processing efficiency and system performance in distributed systems. These validation results provide concrete evidence of the benefits offered by the new approach, reinforcing its value in addressing the challenges of distributed database and information systems. Now, coming to the conclusion, in conclusion, this study offers a comprehensive overview of the state of the art in distributed query processing, emphasizing the significance of modern network technology and challenges inherent in maintaining large, heterogeneous distributed systems. Key insights gleaned from this research include the effectiveness of specialized query processing techniques such as joint optimization, parallel exploitation, and data caching in enhanced query performance and system efficiency with distributed environments. The discussion of different types of distributed systems, including the client server, middle server, and heterogeneous database, offer valuable insights into how query techniques vary on system architecture and data distribution. In the future scope, we may develop specific features like optimization specific architecture, enhance scalability, incorporate machine learning, develop the security and privacy, and real-time query processing, which might be useful for dynamically distributed environments. Here are the references that we used in this study. You can go through all the references. And thank you for giving me this opportunity. Thank you.